some things to begin with, some definitions. Work rate is the fractional portion of a job done in a given amount of time. You're not used to talking that way because the way we usually think of rates is like miles per hour or days per year, okay? But in some cases, the job is the item, and if we know how long it takes to do the job, then the person's rate per hour would be 1 over that rate, okay? Now, a formula that's not in your book that really should be is this. We've done rate times time equaling distance, right? But if we talk about work rate and we multiply it by the amount of time, we're able to establish how much work gets done. Okay? You guys with me so far? Not really, but we're going to try, right? Let's look at Stan the man. Stan can load his truck in 24 minutes. Okay? So his work rate would be 1 over 24. I mean, we're dealing with minutes here because we've got minutes here. So don't worry as long as the units are the same type. Okay? So Stan is 1/24. If Chris helps with an unknown pace, it takes 15 minutes to unload the truck. How long does it take Chris by himself? Now, recognizing that rate times time gives us what we've accomplished, we can create the following equation. Stan's rate times time, which is 15 over 24, 15 over 24, combined with, and I've got that here, Chris's rate times time, which ends up being 15 over x. These two people working together get the job done, the job being one whole unit. Okay? To start with, we're just going to go ahead and find our greatest common factor and start solving. Okay? But the key is the setup. If it takes Stan's 24 minutes, then he does it at a rate of 1/24. Okay? We know Chris does it, but we don't know his rate, which is why the x is in the bottom, 1 over x. We don't know. Okay? One job per, we don't know. Okay? One job per. Okay? Time is consistent because they're both working together. And the product of these two things are here and here. So greatest common factor of all this is going to be 24x. So I'm not going to change anything. I'm just going to start multiplying everything by 24x over 1. 24x over 1, sorry, 24x over 1. For the third, okay? The first one, it cancels out the 24s, leaving me with 15x in the first position. The second one, it cancels out the x's, leaving me with a whopping 360 equals, nothing cancels on the right, 24x. Combine and solve, my friends. Subtract 15, you're going to end up with 9x. Divide by 9, and you're going to come up with x equaling 40. Okay? X equals 40. But what does that tell us? Okay? Remember, we're searching for Chris's rate. Okay, the x is here. That means it takes Chris 40 minutes to do the job by himself. Who's faster, Stan or Chris? Stan the man. Okay? Bonnie and Jean is the exact same scenario as we move into number 14. Bonnie can complete her paper route in 45 minutes. So it's one job in 45 minutes. Okay? 1 over 45. When her sister Jean helps, it takes 18 minutes, which is why 18 is plugged into both positions. How long would it take Jean alone? So just like we were searching for Stan, we are now searching for Jean. Okay? Rate times time gives us work accomplished. This product is 18 over 45. I guess I can squeeze it in. Which, by the way, reduces. So, 18 over 45. You guys want to reduce that by 9? Make our numbers a little cleaner. 5. 18 divided by 9 is 2. 45 divided by 9 is 5. Will that give us the same result? It absolutely will, because this is a fraction, and equivalent fractions are usable. Stay with me, guys. So I'm going to use this. If you don't want to, you don't have to, but to me it's just easier to think about a 5 than it is to think about a 45. So Bonnie is 2 over 5. Added to Jean, which is 18 over x. Why? Because the product is 18 over x. Okay? These two scenarios give us 1. Okay? Greatest common factor of everything is going to be 5x. So, 5x everything. Okay, and you'll end up with cancel, 2x, plus cancel, 18 times 5, 90, is equal to 5x. If you move your 2 over, you have 90 equals 3x. Solving for x, you end up with 30, but what does that mean? Hey, does everybody see my train of thought? I ran out of room, so I went up here, okay? Well, what does that mean exactly? That means her rate is 30 minutes. It takes her 30 minutes. So who's faster? Jean is faster. Okay? Very good. Okay. 2 more. And then I'm going to let you guys try the items that I have from the book. And actually, I'm going to do 1 more out of the book, too. All right. So, an express train travels 150 kilometers. Oh, look, distance, 150. In the same time that a freight train goes 100. Okay. The average speed of the freight train is 20 less than the express. So express is this, freighter is this. Okay? Find the speed of each train. Notice that they converted RT equals D to solve for time. That's why they have that conversion there for you. Okay? Distance divided by rate will give us time. Okay? So literally what we're looking at is the same scenario. Okay? He did this in the same amount of time as he did that. Okay? That would mean that these two things are going to be equal to one another. Okay? So the express train, 150 over R, equals the freight train, 100 over R minus 20. Okay? They give you that little hint here too. Cross multiplying if you like, or solve greatest common factor, I don't care. I like to cross multiply myself, but so 150 times R, 150 times 20, 50 times 2 is 300, 3,000 equals 100R. Making sense so far? Now, if I subtract my 150 over, my 150R that is, I now have negative 3,000 equaling negative 50R, and that's just fine because when I divide out, I'm going to end up with R equaling a positive value of 60. Well, who gets the 60? The express train or the freighter? Who has R? Can anybody see the difference? Who has R? Express train. So he is 60. That means he, 60 minus 20, is 40. Okay? So E, express train, F, 40. Okay? These little hints are always helpful. Okay, the bottom one, fourth example. If Helen can ride 15 kilometers on her bike, at the same time, it takes her to walk 6 kilometers. Okay, so it looks like they're giving me distances here, 15 and 6. If her rate riding is 6 faster, oh good, R plus 6. How fast does she walk? Distance equals rate times time. Well, we don't have time. We don't have time. But we do know I can take time and equate it with distance divided by rate. So, depending upon our scenario, we're going to end up with something very similar to this. Time walking, time riding. So you're going to end up with distance divided by rate, R plus 6, being equal to distance divided by rate. Okay? Because we're looking for time. It's the same amount of time, which is why we can equate those with one another. Okay? Don't think, well, the distances aren't equal. No, but the time is. Which is why when I solve saying this is the same as that, it's true because it's going to allow me to find the rates that will work. Okay. So now I have 15R equals 6R plus 36. 9R is 36, right? I subtracted 6. If I did my arithmetic correctly, I came up with 9. R is 4. So that must be her walking rate, right? If W is 4, then I could say that riding is 10. They actually only ask for walking. Okay? Aren't these fun? Said no one ever? These are difficult. I am fully aware of that. One more example, please, and this one is actually out of your book. If you didn't get all this copied, I'll let you look at it later. But we're going to do the first problem together. You can look at examples 2 and 3 at your leisure. Problem number 1 on page 250. I want to do that one with you guys. This one's really simple, but we haven't practiced it yet, so I want to make sure we do it. Find 2 positive numbers that differ by 8. Okay? So I'm going to say this is n and this is n plus 8. You might be thinking, why aren't you doing n and n minus 8? I just prefer to write it this way. I actually haven't even worked it the other way. I know that this guy is bigger by 8. That works for me. But whose reciprocals differ by 1/6. Okay. That's how I would do it. Two numbers that differ by 8, but whose reciprocals differ by 1/6. Okay? n plus 8, 6. n plus 8, 6. That'll take a while. So 6n plus 8. 6n plus 8 is what you're going to multiply everything by. Okay? So for sake of argument, the 6 disappears here, and I'm going to have n squared plus 8n. I'm not going to write it over and over because it's just too messy. Okay? Now when I multiply this by that, the n plus 8 disappears, and I end up with a 6n. Last one. The n disappears because that cancels out, and I end up with 6 times n and 6 times 8. Okay? There you have it. Simplify. Oh, look, the 6 n's cancel. Isn't that convenient? So we end up with 48 equals n squared plus 8n. Drag your 48 over. 8n minus 48. Factor and solve. And remember, we're looking for positive numbers. Okay? It says positive numbers. So let's see what we end up with. I believe it's positive 12, negative 4. Okay? So these equated with 0, that means one answer is a negative 12, the other answer is a positive 4. Which one should we throw out? Bingo. So your answer is going to be 4 and 12 because I add 8 to it. Okay? Whenever I do these, I use a lot of space. Don't stress about it.